So you've split your orders table into 100 monthly partitions, 12 million rows spread across all those child tables. You write a query for last week's data. Question is Postgres actually skipping the other 99 partitions, or is it quietly scanning everything?
I always assumed partitioning just worked. You add a where clause on the partition key and it's automatic, right?
It can be automatic, but only if the planner can prove at planning time which partitions it needs. That's called planner time pruning. But there are query patterns that force execution time pruning or disable pruning completely, and you won't know unless you actually check the plan. All right, there are two flavors of partition pruning. We need to talk about when each one kicks in.
What's the difference between planner time and execution time?
Planner time pruning happens when the planner looks at your where clause and immediately rules out partitions before execution even starts. You write where order date equals January 1st, 2024, a literal constant. The planner knows exactly which partition holds that data. It builds a plan that touches only that one child table.
So the plan itself is already narrowed down?
Exactly. Run explain, and you'll see only the partitions that survived pruning. Planner time pruning works with constants known at plan time. It's the fastest path because there's zero runtime overhead. The irrelevant partitions simply don't appear in the plan. Execution time pruning kicks in when the planner can't determine which partitions are needed until execution. This happens with prepared statement parameters, PLA/PGSQL variables, or subquery results. The plan will list all partitions, but during execution, the executor evaluates the parameter and prunes before scanning any data.
So the plan looks big, but the actual work is small?
Right. Run explain analyze with a parameter, and you'll see a line indicating the number of partitions removed, such as partitions removed, 97. The cost is low, a few microseconds of startup time, but it's not zero like planner time pruning. And execution time pruning can occur at various levels of the plan, though it may not be effective in all scenarios like nested loops, where parameters change per row. Here's a query with a literal date constant. The planner sees the constant, matches it to the January 2024 partition, and the plan shows only orders _2024_01. No mention of the other 99 partitions.
And the planning time is just 1/3 of a millisecond?
Correct. Planner time pruning adds almost nothing to planning cost. The execution scans one partition, hits the index, finishes in 50 microseconds. This is the gold standard. The other partitions were never even considered. Pruning only works if your where clause matches the partition key in a way the planner or executor can understand. There are shapes that enable it and shapes that silently break it.
What counts as a match?
Isquality, ranges, and in-lists all work as long as they directly reference the partition key column. Simple comparisons work well because the planner can map them to partition boundaries, and combined predicates work too. The pruning logic extracts the partition key predicate and ignores the rest.
What about OR conditions?
Or works if both sides constrain the partition key, where order date equals January 15th or order date equals February 20th, will prune to two partitions. But if one side of the OR doesn't mention the partition key, pruning fails and you scan everything. That's a common trap. Any expression that transforms the partition key can prevent pruning because the planner can't invert the logic to figure out which partitions match. Extract, date trunc, typecasts, or any function that wraps the column, they can prevent partition pruning. Complex subqueries also disable pruning because the planner can't evaluate them at plan time.
So even something as simple as a cast can kill it?
Yes. If your partition key is a date and you cast it to text, the planner sees an expression, not a column reference, and gives up. The fix is to rewrite the predicate so the partition key stands alone, cast the constant instead of the column, where order date equals quote 2024-01-15 quote : date works fine because the key itself is bare. Here's the classic mistake. The query wants all 2024 orders, but extract wraps the partition key in a function. The plan shows an append node with every single partition as a child, orders_2024_01 through orders_2024_12, all 12 monthly partitions from that year, and each one gets a sequential scan. Execution time jumps to 8 seconds for a query that should take milliseconds.
And the fix is just to rewrite it as a range?
Exactly. Where order date greater than or equal to January 1st, 2024, and order date less than January 1st, 2025. Now the partition key is bare, the planner prunes to the relevant 2024 partitions, and execution drops to a few milliseconds. Same result, 3 orders of magnitude faster. Even when your where clause looks fine, certain query patterns disable pruning in ways that aren't obvious. These are the traps that catch experienced developers.
What kind of patterns?
Picture a nested loop join where the inner side is your partition table and the join condition references the partition key. Something like from customers join orders O on O dot order date equals C dot sign up date. The partition key value changes for every outer row, so planner time pruning can't happen because the planner doesn't know the values. Execution time pruning can prune partitions during execution, but its effectiveness depends on the executor's ability to determine needed partitions based on runtime values of the partition key.
So it still prunes, just at execution time?
Right. But the overhead of evaluating partition constraints per loop iteration can add up. If you have an index on the partition key, lookups are efficient. But if you see high execution times with this pattern, think about rewriting as a hash join or pre-filtering the outer table to a narrow date range. Some legacy code manually unions child tables. Select asterisk from orders 2024-01, union all, select asterisk from orders 2024-02, thinking it's helping the planner. But this bypasses the partition infrastructure entirely. The planner treats them as separate tables, and union all forces all listed tables to be scanned, bypassing any partition pruning logic. Every table in the union is scanned, and you lose the benefit of partition-aware planning.
So you should always query the parent table?
Yes. Query the parent and let the planner handle pruning. The only exception is if you're doing partition-specific maintenance, like vacuum or analyze on a single child, but for application queries, always use the parent table name. Aggregates are another trap. This query counts shipped orders, but the where clause doesn't mention the partition key. The planner has to scan every partition to find matching rows. The plan shows many child scans under the append node, and execution takes 9 seconds, even though most partitions might be empty or irrelevant.
But what if I genuinely need all-time counts?
Then you pay the cost. There's no magic. But often the business question is really about recent data. Adding a partition key filter like and order date greater than or equal to current date minus interval quote 90 days quote prunes to 3 partitions and drops execution to milliseconds. Always ask whether the aggregate truly needs historical data or if a recency filter makes sense. By the way, my DBA's free health check continuously analyzes your pgstat statements data and flags queries that are scanning way more partitions than they should. It'll show you the query, the number of partitions hit, and suggest the exact where clause rewrite to enable pruning.
So it catches these patterns automatically?
Exactly. It's one of dozens of checks in the query performance domain. You connect your database, and within a few minutes you'll see a graded report, A through F across 16 domains, with every finding paired with the runnable fix. And it keeps running week after week, so you catch new problems as your queries evolve. One way to know if pruning is working is to check the plan. But other methods like analyzing query performance metrics can also help.
What should I look for in the plan?
Explain Analyze is a key tool. Look at the append node and count how many child scans appear. If you're querying 1 month and see 12 children, pruning worked. If you see 100, it didn't. The partitions removed line tells you planning time pruning happened. Buffers hit is another clue. If you scanned 10,000 buffers, but the partition you care about is only 100 blocks, you hit other partitions too.
What about in production, when I can't run explain on every query?
Monitor each partition individually using pgstat, all tables, or similar views that include partitions. If seek_scan or idigexscan counts are climbing on partitions that shouldn't be accessed, like old historical partitions, you've got a query that's not pruning. Cross-reference with pgstat statements to find the query text, and set up alerts on partition scan rates so you catch it early. When pruning works, you get sub-second queries even on tables with billions of rows because you're only touching 1 or 2 partitions. Planning time is low, execution time is low, buffer hits match the partition size. When pruning fails, you scan hundreds of partitions, execution time jumps to seconds or minutes, and buffer hits balloon to millions. The difference is not 10%, it's 3 orders of magnitude.
So it's really binary. It either works or it doesn't.
In most cases, yes. Pruning can be partial, where only a subset of partitions is scanned based on the query conditions. But often it's all or nothing. Either the planner or executor can eliminate partitions effectively, or you end up scanning far more than you need. That's why verifying the plan is critical. You can't assume it's working just because you added a where clause. Check the plan, count the children, make sure the numbers match your expectations. If you want to know whether your partition queries are actually pruning, or if you're silently scanning every partition, connect your database to MyDBA at mydba.dev. It's free, takes a few minutes, and you'll get a comprehensive health report that flags partition scan issues, slow queries, missing indexes, and dozens of other problems, each with the exact SQL fix. The report lands in your inbox every week, automatically.
And it's really free?
Completely free. You connect your own database, and it starts collecting telemetry just like it would for a paid managed database. The first report shows up almost immediately, and over the first week it grows into a full A through F grade across 16 domains. After that, a fresh report every week. Go to mydba.dev and start your health check now.